Okay, this is test review number 1 from Math 203. You should stop the video, read the problem, work the problem, play the video. So when I go to the next problem, you should stop the video, read, work, play. All right, so we're going to get started with the first problem here. If you read the problem, apparently we went out and took a sample of black cherry trees and we measured their heights, and then we grouped the trees into different categories or classes or intervals, as you can see on the screen here. We're going to construct the frequency table associated with this particular histogram. All right, so if you recall, these numbers right here represent the lower class limit. So I know my first class starts at 60, my second one 65, my third one 70, 75, 80, 85, and, well, 90. Okay, now there is no class here because it apparently is empty. But anyway, the upper class limits, you recall, since we're working with integer data, is going to be one less. So on the diagonal, 64, 69, 74, 79, 84, 94, and then 99. Again, we don't have any data here, but it's okay to put an extra interval there if you'd like to choose to do so. Anyway, our frequency is the height of the ball. Now we don't have any numbers up here, and that can happen. If you're not given the numbers, you're going to have to figure it out by looking to the y-axis or the left side vertical axis, which is the frequency here. Our first class, the height is 3, so the frequency is 3. For the second class, the same height, 3. The third class, the height is apparently 8. For the 75 to 79 class, it appears to be 10. Then we go down to the 80th to 84th class, and I would say that was a 5. The next one looks like 2, because if it was 1, it would be really short, so 2. And again, this last class, you can either include or not include, it's 0. So our sample size is the total of all these frequencies here. So if we add up our frequencies, we have 6 and 8, 14, 24, 29, 31. I get 31 for my frequency. Moving on, the relative frequency of the third class is what? Well, the third class is right here. The frequency is 8. But we want the relative frequency, so we have to divide by 31. So 8 divided by 31 is the relative frequency, but we want the answer to 2 decimal places, so that is 0.26 or 26%. Reading the next one, the relative frequency of the number of trees that are at least 75 feet. So at least 75 feet, we'll go up here and work this one out. So the trees which are at least 75 feet, there were 10, then 5, then 2, and again, since we want relative frequency, we divide by the sample size, which was 31, and so we have 17 divided by 31, and converted to a decimal number, 0.55. Moving on. Now the histogram is suggesting the data distribution is what? Well, again, there were 4 different types of data distributions: left skewed, right skewed, bell-shaped, and uniform. Well, if we look here, we tend to go up and then we tend to go down. So since we have 2 tails on each side, and again, if you kind of smooth this out a bit, it looks like a hill, we will assume this is bell-shaped data. All right, now we're going to move on to the next problem. Again, you should be stopping the video, working the problem, and then playing the video. Now in this problem, we would like to create a frequency distribution for the given data. We're going to be working with a class width of 9, and we note that the data is sorted. So the data is sorted from here. Don't have to be sorted, but I'm just making it easier for you so that you can focus on the table itself. Well, this is numerical data. So we're going to choose our first class limit to be the smallest data value, which is 5. Now, we have chosen a class width of 9, so we're going to be adding to 5, 9. 9 and 5 is 14. 14 and 9 is 23. 23 and 9 is 32. 32 and 9 is 41. So here are our lower class limits. Our upper class limits, well, again, if you go on the diagonal, it's going to be 1 less, so that's 13, 22, 31, and 40. And then if you add 9 to this one would be 49. Now, as I mentioned, any two successive numbers vertically wise should differ by 9. So if you look at the differences here, they all should differ by 9. Now we need to just figure out the frequency of each individual class. So I'm going to look for all numbers that are between 5 and 13. 5 and 13 is this set of numbers. That's why it is nice to have it sorted. So we have 5 numbers. Frequency is 5. Between 14 and 22, right here, 2, 4, 4 numbers. 23 and 31, there are none, 0. 32 to 40, 4 numbers. And we have no numbers in our last class, so we'll just put 0 there. And again, if you left that last class out, it'd be okay. But this middle class, you should not remove because the frequency is 0. Now, our relative frequency is the frequency divided by the sample size, or the number of pieces of data collected. How many pieces of data did we collect? We collected 13 pieces of data. So our sample size was 13. So this is going to be 5 divided by 13. 4 divided by 13. 0. 4 divided by 13, and 0. All right, so again, we typically convert this to a decimal number, and so we should, well, they want it to 1 decimal number as a percent to 1 decimal number. So you do need to read your instructions, right? So I'm going to convert this to the decimal percentage. So when I do the math, this relative frequency turns out to be 38.5%. This one here turns out to be 30.8%. Now this one is 0. Now since we really only have one more class left, this is supposed to add up to 100%. Notice if you add these two numbers together, you get 69.3%, meaning that we are going to adjust this one to 30.7% because we want these totals to add up to 100%. And this is definitely 0. So if it's a 0, it should be a 0. But again, these are decimal numbers, irrational numbers. They have to be rounded. And there is our frequency distribution table. Okay, pause the video. All right, so we're going to calculate the mean for the given data here. The mean is simply add up the data. Divide by how many pieces of data you have. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 pieces of data. And so our mean is going to be equal to So when you add the numbers up, you get 20. 20 divided by 9. We want a decimal number to one place, so decimal number to one place would be about 2.2. 2.2. Okay, for the median you have to sort your data. So for the median, oh, and this is a sample, so I'm just noting this should be X bar. The median, you have to sort your data, so we're going to sort our data. -7, -1, -1. We have a 1, then a 2, then a 3, then a 5, then an 8, then a 10, and double check. Okay, so -7, a -1, -1, then I see a 1, then I see a 2, a 3, a 5, an 8, and a 10. So I believe it's sorted. And then the median, you slice it in the middle. So we pair the numbers off. And there is a 2 smack in the middle. So the median is 2. Our mode is the number that occurs the most. So if you look at the data, the number that occurs the most apparently is a -1. Okay, in this problem we are looking to do the standard deviation for a sample of data. You need to stop the video, work it out, and then compare what you got to what I got. All right, so the first step is we need to calculate the mean. So you show yourself that the mean is equal to 15 divided by 5, which is equal to 3. So the mean is equal to 3. In our second step, we are going to construct a table. I'm going to list the data. So I'm going to list my data. -1, 1, 2, 5. That's a 5. And then an 8. So I'm going to list my data. The second thing, I'm going to subtract the mean. -1 minus 3, -4. 1 minus 3, -2. 2 minus 3, -1. 5 minus 3, 2. 8 minus 3, 5. So I subtracted the mean from the data values. Then I'm going to square this. -4 squared is 16. -2 squared is 4. -1 squared is 1. 2 squared is 4. 5 squared is 25. Then I'm going to add up this column. So adding this up, 10, 15, 15 and 5 is 20. 2, 3, 4, 5, 50. So I get 50 from my sum of my squares. Step 3. Now, depending on point, if it's a sample or population, this is a sample. So I'm going to take the 50 and I'm going to divide by the sample size -1. So I'm going to get 50 divided by 4. Now this is the variance right here. That's the variance. Okay? Well, we want the standard deviation, and the standard deviation is the square root of this number. So we're going to take the square root of 50 divided by 4, plug it into the calculator, and we get, rounded to one decimal place, 3.5. So answer is 3.5. Moving on. Okay, stop the video, work the problem. In this problem, we are associating a percentage of data that falls in a particular interval. So when we're associating the percentage of data in an interval, it's either going to be Chebyshev's or the empirical rule. We see nothing about bell-shaped distribution. So this is Chebyshev's rule. So we're going to be working with two formulas here. The Chebyshev's formula, which says the percentage of data is about equal to 1 minus 1 over k squared. Our other formula is going to be equal to D is equal to k times sigma. Now, since we are given the interval, we're going to start off on this side here. In other words, we know the interval is 2, 18, and we know in the middle is supposed to be the mean, which is 10. So the distance to an endpoint is 8. So we know D is equal to 8. K is unknown. That's what we're trying to find. The standard deviation is 4. And when we solve for K, we get K is equal to 2. So K is equal to 2. We're going to bring this over to the Chevyshev's formula, and that's how we link it to the percentage. So the percentage is 1 minus 1 over K squared, which is 4. Well, that is 3/4. Now, you're supposed to know basic algebra. So show yourself that 3/4 is 75%. So about 75% of the population is going to be between those two numbers. Moving on to B, we now want to find an interval that contains 70% of our data. So this time, again, we do not know this is bell-shaped, so we're going to be working with the Chevyshev's formula. We're going to be working with this formula and starting at this point because we are given the percentage. So the percentage is equal to 1 minus 1 over K squared. In other words, we need to solve this equation here. 0.7 is equal to 1 minus 1 over K squared. Now, I'm going to let you do the algebra because this is not an 092 course. This is a Math 203 course. You need to understand how to solve basic equations. So I'm going to get right to the answer here. Okay, so when you solve for K, you should get K is equal to the square root of 1 over 1 minus 0.7. So K is going to be about equal to 1.83. Now you're going to bring it over to the distance formula where the distance is equal to K times sigma. We know K is 1.83. We know sigma is equal to 4. When we do the math, we get the distance is 7.32. So our interval, which is centered at the mean, 10, we're going to be adding 7.32, and we're going to be subtracting 7.32. And so our interval is 17.32 up here, 2.68 down below. Oh, and the answer is 2.68 for the lower interval. Once again, you should be pausing the video, reading the problem, working it out. All right, so we have a problem here where, again, we are associating the percentage of data to a given interval. Well, this time we see a very important word here, and that is bell-shaped. So we are going to be working with the empirical rule here, the empirical table. And that table right here is given by K, and then the percentage. So 1, 68, 2, 95, and then 3, 99.7. Over here, we're going to be working with that formula, D is equal to K times sigma. Since we're given the interval, we're going to be able to find D. Because again, the mean is in the center. And so our distance is 20. So 20 is equal to the unknown value K times sigma, which is 20. So K turns out to be 1. If we bring this over here in the table, K is equal to 1, is indicating that about 68% of the population will fall in that interval. For part B, we're given the percentage here, and we're trying to find the interval. So we're going to be working on this side. We look up 95%. and we find out that k is equal to 2. We bring it over here. Our distance is 2 times sigma, which is 20. So our distance is equal to 40. So the interval, which is centered at 800, is determined by adding 40 and subtracting 40. Well, we get the interval now is 760, 840. So that's the second, or part B of this problem. Okay, for this problem, we're given a frequency distribution table. So thinking about the definition of the mean, if we want to calculate the mean given this data here, we're going to have to take each price, multiply it to its frequency, then divide all this by the sample size, which is 20. You do the math and you will find out that the price is, well, we get a mean price. I meant to say mean price, but we get 65.9 divided by 20. And when you get that number, about $3.30. Now the mode is the number that occurs the most. Well, by looking at the table, it's clear that it is 3.29. Okay, I should have fixed this in the original PDF file, but we are going to work with the assumption that this is bell-shaped data. Okay, we're going to work with the assumption that we are working with bell-shaped data. Now we have two factories here. And for factory A, if you read the problem, the mean number of days is 8, and we're trying to determine the percentage of data that is above 9. Okay? At least 9 days, right? So we're actually trying to find out what's out here. Well, if you work with the empirical rule, because it is bell-shaped, the distance here is equal to 1. Since the standard deviation is 1/2, k is equal to 2. From the empirical rule, you can look at the table. When k is equal to 2, the percentage of data in this interval is about 95%. Now for factory B, its mean is equal to 6. And again, we're looking at the percentage of data beyond that point. So we're looking at this interval here, which is that. Well, its standard deviation is 3. The distance is 3, so in this case, k is equal to 1. Well, again, assuming bell-shaped distribution, we have about 68% of the data that's in this interval. Now, here's what you have to think about. If 95% of the data is in the interval, that means 5% of the data is outside of the interval. Well, that's above and below, so we really have to divide this by 2, which means about 2.5% of the data is going to be above 9. For this one here, once again, 68% of the data is in here, which indicates that about 32% of the data is on the outside. But we have two outsides, down here and down here. So we have to divide that by 2. And half of 32 is about 16%. So about 16% is above this number here. So we suspect factory A is going to, factory B is going to have a higher percentage of workers being sick at least 9 days.